This is section 6.3, part 1. We're going to talk about binomial radical expressions, and this time we're going to talk about adding and subtracting. We've talked about multiplying and dividing, and we're going to talk about adding and subtracting now. Our objective here is we're going to add and subtract radical expressions, multiply conjugates and rational denominators. So the first part here, for part 1, we're going to add and subtract them, the radical expressions. Okay. So like radicals are radical expressions that have the same index and same radicand. Now, when you add and subtract radicals, it's very similar to like terms with variables. Okay. Yeah. If I have a 3x and a 4x, I can add those together. But if I have a 3x and a 4y, I can't add those together because they're not like terms. Radicals are very similar. They have to have the same radical, okay, and they also have to have the same number underneath the radical. So they have to have the same index and the same number underneath the radical in order to add them together, okay? So you'll see like radicals with numbers, if I take the square root of 2 plus 3 square root of 2, that's going to be 4 square root of 2. You treat these, again, these are just like variables, so this would be like x plus 3x is 4x. Same thing if we have a cube root, the cube root of 7 minus 5 cube root of 7 is negative 4 cube root of 7. Okay. Same thing if you add variables in here. You have the square root of 5xy plus 8 square root of 5xy is 9 square root of 5xy's. Okay. Again, you're going to treat them just like you would a variable. And that's essentially what this is here. This is a summary of what I was just talking about. So, using the distributive property to add and subtract like radicals. If I have a times the nth root of x plus b times the nth root of x, that's essentially going to be able to take a and add it to b times the nth root of x. Okay, you're going to be able to add the two things that are on the outside. Okay, so same thing with subtraction as well. Now, I've got some directions here in order to be able to add and subtract. First one, roots must have the same index and the same number underneath the root in order to be able to add or subtract them. We just got done talking about that. Okay? If they're not the same root or number underneath the root, then you cannot simplify it. You just leave that as your answer. Okay? Sometimes you're going to have to simplify your roots first in order to combine with addition or subtraction. You're going to see that towards the end of today's lesson. Okay? Okay, let's take a look at some examples on the next page. Okay, so what is the simplified form of each expression? So as we look at this, first thing we're going to check is, as we look at this problem, are the roots the same? Those are both square roots. What's underneath the root, are they the same? They both have a 5x. So we are going to be able to combine these. So 3 square root of 5x minus 2 square root of 5x is essentially just 1 square root of 5x, or if you just make that the square root of 5x, that would be okay as well, either way. Okay? So we can combine those. Notice again, you treat the square root of the square root or the root just like you would a variable. Okay, problem 2. You notice here we have a square root of 7 and a square root of 5. These do not have the same numbers underneath. I cannot simplify this. Okay, you cannot simplify it. It has different numbers underneath the root. So essentially, this is just as far as I can go. I can't do anything with that. Okay? Third one, you have the cube root of 7xy and the fifth root of 7xy. Well, the roots aren't the same. So, in this case, I cannot simplify. That's as far as I can go. The roots are not the same. The indexes have to be the same. Okay? Next one. The 7 times the cube root of 5 minus 4 times the square root of 5. Well, as you look at this, this is a cube root of 5 and a square root of 5. These indexes are not the same. I cannot simplify this. This is my final answer. Now, as you look at these more and more, the problems you're going to see, you're not going to sit here and have a bunch of cannot simplifies. Okay, they're going to give you some problems where you're going to be able to simplify them. Letter B. Okay, 3x times the square root of xy plus 4x times the square root of xy. You'll notice these are exactly the same. The roots are exactly the same. So I can add 3x and 4x is 7x, and I bring along the square root of xy. And then letter C, okay, you'll notice that I have the fifth root of 3x squared and the fifth root of 3x squared, so these are like terms. So I can take 17 minus 15, which is 2, times the fifth root of 3x squared, and you're done. Okay, so the key is being able to make your roots or have roots that are going to be exactly the same, both indexes and also the numbers underneath. Okay, what happens if the numbers underneath aren't the same? Okay, well there are some situations where you can simplify these to make the radicals the same. So when you have a sum or difference of radical expressions, you should simplify each expression so that you can find all the like radicals. So in other words, you can break some of these guys down and be able to simplify them. For example, 12 with a square root of 12, I know that 12 is 2 squared times 3. So essentially, this is the square root of 2 squared times 3 plus 75. 75 is 5 squared times 3, 25 times 3. So this is really the square root of 5 squared times 3. And then I can subtract the square root of 3 on the end, because there's no way to break down the square root of 3. Well, this goes back to simplifying. The 2 can come out front, and I've got a square root of 3. Plus the 5 can get out of jail with a square root of 3. And now, if you notice these, all of these have the same root. So what does that mean? I can combine them. 5 plus 2 is 7. Minus 1 ends up being 6. Square root of 3. Okay? Same situation with this problem. If I take 250. 250, again, on the cube ones, I want a cube. So 250 is 5 cubed times 2. 54 is 3 cubed times 2. And 16 is 2 cubed times 2. Okay, so I can break all these down. Essentially, I have the cube root of 5 cubed times 2 plus the cube root of 3 cubed times 2 minus the cube root of 2 cubed times 2. All my cubes will get out of jail. So I have 5 times the cube root of 2 plus 3 times the cube root of 2 minus 2 times the cube root of 2. All those ones got out of jail. Now you'll notice, again, all of my roots are exactly the same underneath and along with the indexes. So I can add these terms together. 5 and 3 is 8. Minus 2 is 6 times the cube root of 2. Okay? So you can also break down numbers and simplify them in order to be able to find like radicals to add and subtract. Okay, so this completes section 6.3 part 1. Don't forget to complete your WSQ.